Time. It's something we live by every single second of our lives, right? We feel it, pushing us from the past, through this moment right now, and into whatever comes next. But what if that feeling, that whole idea of a constant flow, is just, well, an illusion? We're going to dive into the incredible physics of what time really is, and why our most basic, gut-level intuition about it might be completely and utterly wrong.
We almost always think of time like a river, just flowing relentlessly in one direction. It's this powerful common sense idea. And honestly, it's captured perfectly in this famous painting by Salvador Dali. See how the clocks are melting, they're flexible, but they are still moving forward. It feels right, doesn't it? But as we're about to see, in physics, common sense can be a bit of a trap.
And who better to come along and shatter our common sense than Albert Einstein himself? He called our most fundamental experience of time a stubbornly persistent illusion. This right here, this is the central conflict we're going to explore. It's our gut feeling versus what the actual laws of physics are telling us.
Now here's where it gets really weird. At the most fundamental level, we're talking about the deep-down equations of physics. They don't care about the direction of time. They work just as beautifully whether you run the clock forwards or backwards. So if the laws themselves are symmetric, why is our reality so obviously one way? Why do we remember the past but not the future? What is going on?
To figure that out, we have to look for the biggest clue we've got, what's called the arrow of time. It's the reason a broken egg never, ever reassembles itself. And the key to understanding this whole thing is a concept that governs everything from a car engine to the entire universe. And that concept is called entropy. Now, to put it simply, entropy is just a measure of disorder. And the second law of thermodynamics, which is one of the most rock-solid laws in all of physics, says that in any closed system, like, say, our universe, the total amount of disorder can never, ever decrease. It only goes up. Always.
And this slide just illustrates the point perfectly. A tidy room, that's a low entropy, highly ordered state. A messy room is high entropy and, well, disordered. You see, there are just vastly more ways for a room to be messy than for it to be tidy. So the universe just naturally moves from these less probable, ordered states to the much more probable, disordered states. An egg doesn't unscramble itself for the exact same reason a messy room doesn't spontaneously clean itself. It's all about probability.
So the genius who first connected all this to time was a physicist named Ludwig Boltzmann. He came up with this really radical idea back in the late 1800s. He said maybe the flow of time is nothing more than the universe moving towards a state of higher entropy. The future is just the direction of more disorder. It was an incredibly controversial idea at the time, and the fierce opposition he faced from other scientists tragically contributed to his depression and ultimately his suicide.
But what's so fascinating is that Boltzmann's arrow of entropy isn't the only one we found. Physicists have actually identified several arrows of time, and the crazy thing is they all point in the same direction. From the cosmological arrow, the fact that the universe is constantly expanding, to the psychological arrow, the simple fact that we remember yesterday and not tomorrow. They all create this unshakable one-way street. So the universe really seems to have a built-in direction.
Okay, so we have a direction for time. Great. But that still doesn't tell us what time is. For that, we need to leave the 19th century behind and jump ahead to the 20th, where Einstein just completely tore up the rulebook and gave us a whole new picture of reality.
For thousands of years, our thinking about time evolved, but really slowly. Aristotle saw it as just a measure of change. Then Newton came along and formalized it as this kind of cosmic clock, ticking away at the exact same rate for everyone, everywhere. It was this fixed, absolute background to reality. And then, in 1905, Einstein just blew that entire idea to pieces. And he did it with a really simple but profound thought experiment, the light clock. Okay, so imagine a clock that ticks every time a little particle of light, a photon, bounces between two mirrors. Now, what if that clock is moving? Well, from an outside perspective, that photon now has to travel a longer, diagonal path to catch up. But, and this is the absolute key, the speed of light is constant for everyone. It never changes. So if the distance the light travels is longer, the time it takes must also be longer. Time itself has to slow down for the moving clock. And that leads to this just incredible conclusion. Time is not absolute. Your experience of time literally depends on how fast you're moving. Astronauts on the space station are actually aging a tiny, tiny fraction slower than we are down here on Earth. Time is personal. It's relative.
But Einstein wasn't done. He went even further and he merged space and time into a single four-dimensional fabric he called space-time.
This light cone diagram is a great way to visualize it. So you, the observer, are right there at that single point of the present. Your past is everything inside that bottom cone, every event that could have possibly affected you. Your future is everything inside the top cone, every event you can possibly go on to affect. And anything outside those cones? It's just too far away in space and time for it to ever have an impact on you or for you to ever have an impact on it. So time is part of this bendable, stretchable fabric. Which of course leads to the next big question. If we can bend and stretch space-time, can we also, break it? This is where we get into the really wild, speculative edge of physics.
This is the kind of question that fuels science fiction, for sure, but it's also a deadly serious one in theoretical physics. Can we manipulate space-time so much that we could actually travel through time itself? Well, according to Einstein's own theories, the answer is a very strange, mind-bending maybe.
The scientific term for what we'd call a time machine is a closed timelike curve, or a CTC. Basically, it's a path through space-time that's been so warped by gravity or motion that it actually loops back on itself, allowing you to arrive at a point in your own past. And the weirdest part is that general relativity totally allows for these things to exist, at least on paper. But as you can imagine, these CTCs create huge problems for causality. The most famous one is, of course, the grandfather paradox. The logic is just a nightmare. If you go back in time and prevent your own birth, then you could never exist to go back in the first place. It's a complete contradiction that seems to make backwards time travel totally impossible.
So how do physicists try to solve this? Well, there are two main ideas. The first is something called Novikov's self-consistency principle, which basically says that the universe just won't allow paradoxes to happen. You could go back in time, sure, but you'd find yourself physically unable to change the past in a way that creates a contradiction. The other big idea came from Stephen Hawking. He called it the chronology protection conjecture. He argued that the laws of physics themselves would basically conspire to destroy any time machine before it could ever be used.
All of this brings us right to the very edge of what we currently understand. It seems like the more we learn about time, the more questions we have. And these questions, they challenge our most basic assumptions about what reality even is.
Okay, get ready for this one, because it's a real mind-bender. It's an idea that comes out of relativity called the block universe. If time is just another dimension, like up-down or left-right, then this theory suggests that the past, the present, and the future all exist simultaneously, all at once. Our feeling of now is just our consciousness moving through this static block. Think about what that means for a second. If this is true, it pretty much suggests there's no real free will. The future is already set in stone, just as much as the past is. And the frontiers of physics are only getting stranger. Just recently, scientists actually created something called time crystals. Now, regular crystals, like a diamond, are just atoms arranged in a repeating pattern in space. Well, time crystals are quantum systems that repeat a pattern in time. They move in a loop forever without using any energy. It's a brand new phase of matter that seems to have its own internal clock, and it fundamentally defies our normal understanding of time's error. Which leaves us with this final, deeply unsettling thought. If that block universe view is correct, then the past hasn't vanished. It's still there, a permanent part of the space-time fabric. And even more profoundly, the future is already there too, just waiting for our consciousness to catch up to it. So, is our experience of choice, of an unfolding, unwritten future, just that, a stubbornly persistent illusion? The physics is far from settled, and honestly, the answer could change everything we think we know about reality.